lecture series. It's lecture number 14, Applied Calculus series. Our topic is limits at infinity. I request you kindly subscribe the channel and like the video. Limits at infinity. Sometimes we are concerned with the behavior of the function f of x as the magnitude of the variable. Say x increase without bound means the magnitude becomes infinitely large. The limits stored in such instances are called limits at infinity, and we write as limit x tends to f of x or x tends to minus infinity f of x. What about this notation? X tends can be read as x increase without bound, or x tends towards infinity. Similarly, x minus read as x decrease without bound, or x tends towards minus infinity. This symbol infinity, the Englishman John Wallis 1673 was the first to use the symbol infinity. Observe this function f of x 1 over x. Larger x becomes means x tends to infinity. What about this 1 over infinity? Closer 1 over gets to 0 means you will have f of x closer to 0. Here is a situation and showing in table. The graph of f of x is also shown that as x becomes large. See here x 1 over if we put x is equal plus minus 2, you will have y plus minus 0.5. We apply x is equal to plus minus 10, you will have plus minus 0.5. Similarly, if you x replace plus minus 100, then you will have y plus minus 0.01. Similarly, if we apply x plus minus 1000, then y from y we have plus minus 0.01. Means if we goes to without increase x increase without bound, we will add 1 over x closer to 0. You can also see the situation from the graph. As you see, graphs goes to 0 as we on x-axis x goes to infinity. Similarly, if here on x-axis goes to minus infinity, we will have 1 over x graphs closer to 0. You see, we say that the limit of as x increase without bound is 0. This is written as limit x tends to 1 over x is equal to 0. And similarly, we can determine that limit x tends to minus infinity 1 over x is 0. Yeah, the above limits only describe the behavior of 1 over x as magnitude of x increase without bound. They describe the tendency of 1 over x towards 0. As x tends towards infinity, consider the next. If we have 1 over x power n, then we can say limit x tends to 1 over x power n is also 0. So limit x tends to minus 1 over x power n is also 0 as n is a positive integer. So if we compare 1 over x power n, notice that magnitude of x is larger than the magnitude of x, but when x approaching infinity or minus, then follows that the function is c over x power n, and also we have limits tends to 0. If c is a finite constant, then the limits as x increases or decreases without will still be 0. Now examples. I request you kindly subscribe the channel as you find more videos on the mathematics topics. Now example, limit x tends to infinity. If we apply direct numerator, we have polynomial and denominator also, we apply the limits, so we will have infinity over infinity form. So in that situation, we take the common. Here from numerator x cube is common, rest is 3 minus 8 over x square plus 1 over x cube. In denominator, we again take the common x cube, so we have the rest 4 minus 3 over x minus 16 over x cube. With x you can divide and multiply, we can say divide or multiply x cube in numerator and denominator. We have this situation, x cube will cancel x cube. Limit x tends to infinity. Now apply the limit 3 minus x, replace with infinity. So 1 over 8 over x infinity square, 1 over infinity give 3 over infinity 16 over that all, they all goes to 0. So we will have 3 by 4. So answer is 3 by 4. X cube plus 2x square x limit x direct you apply x tends to infinity, x is equal, you will have the infinity r. By this transformation x is equal to 1 over y, so we x replace with 1 over y, so x cube 1 over y cube minus 2x square 1 over y square plus 1. If y in this transform x tends to infinity, then what about the y? Y is equal to 1 over x. If we apply x tends to infinity, y tends to 0. So if we put the limit y tends to 0, we will have 1 minus 2 0 0. 1 over 0 is infinity. This shows that above limit does not exist. The idea of dividing each term by a power of is used only for limit setting. It will not help in the value other kind of limits. Another example, limit x tends x4 x cube. Here numerator maximum common is x4, so we will have rest is 1 over 5 over x cube minus 6 over x4. Here in denominator we have x cube common, so 1 plus 1 over x minus 6 over x cube. So x cube will cancel with the x4, just we have the x here. Apply the limit infinity 1 here 5 over x cube, x is equal to, so it goes to 0, this one is goes to 0, this one goes, that one is goes to 0. So we will have infinity 1 plus 0 1, 1 plus here is a 0 not 1, so you write next here as 0. We have that means the limit of the given function also does not exist. Here is another example, limit x tends to the x square plus 5x3 by 2 plus 7. Limit x tends to infinity, we take the from numerator x square is common. X square is common, so rest is 1 plus 5 over x square. Denominator we have taken the common x3 by 2, so rest is 1 plus 7 over x3 by 2. X square x3 by 2, so x power 2 minus 3 by 2, so we will have x 1 by 2 because 2 minus 3 by 2 is equal to 1 by 2. Apply the limit x, replace with infinity, x 1 by 2 is infinity, 1 plus 5 x is infinity, so 5 over infinity is 0, so 1 plus 7 over x cubed, x 3 by 2, so x replace with infinity, so 1 plus 7 over infinity is 0. So 1 multiply and we will have increase of function. Limit of given function does not exist. Limit x tends to infinity, a power x minus 1 over x. Here a is greater than 0. We apply the binomial theorem by putting by this transformation a is equal to 1 plus a. So a replace with 1 plus h power 1 plus h. So x here x minus 1 x x. Apply here binomial theorem, so we will have 1 plus x h a plus x x minus 1 h square over 2 factorial minus 1. So 1 will cancel with 1, we take the x common, so we'll have x h plus x x minus 1 h square 2 factorial, x will cancel with this. Now apply the limit x tends to infinity, so h here x is means infinity, in all other terms we will have h plus, so infinity add with any number we will have infinity, means thus the limit of given function does not exist. Another example, limit x tends to infinity, x square over x plus 1 minus x square x, we have taken the x square is common, so we will have rest 1 over x plus 1 minus 1 over x plus 3. Take the LCM, so we will have x plus 3 minus x minus 1 x plus 1 x plus 3. X cancelled with minus x, 3 minus 1 is 2, so we will have just 2. So in denominator take first multiply with x plus 1 x plus 3, so x multiply with x square x with 3 and 1 with x, so we'll have 4x, 1 with 3, so we'll 3. Take the x square is common, so here is x square is common, so 1 plus 4 over x is rest plus 3 over x square. Now apply the limit to 1, 4 over x, x tends to infinity, 4 over infinity is 0, 3 over infinity square is 0, so we will have 2. We have completed the limits at infinity. I request you kindly subscribe the channel and like the video. Thank you.